Hello, everyone. My name is Kyle Mane, and I'm the teaching fellow for S171, Water, Health, and Sustainable Development. What I'm going to take you through here today is actually the tutorial 3 on GIS applications. And so if you go to canvas.harvard.edu, log in with your Harvard ID, and then navigate to our course website, S171, the Summer uh, Water, Health, and Sustainable Development course, you'll find yourself at this page. If you click on the Assignments tab, you'll be able to see this right here. And this is the various assignments. You can click on Tutorial 3, and we'll go through this together. The assignment notes that it's due on July 22nd. It's worth 15 points, and you'll be submitting a file upload. It also notes a few things. One, that you should read through this entire assignment page. You'll have the option to install Qgis, which is a GIS program. And we have instructions under Class 5, Tutorial 2, and we'll navigate to there together. We'll also want to read through all questions below. Optionally, you can skim material inside of modules. This includes the data, tutorial2.zip, and the original slides, tutorial2 intro.pbtx. We suggest that you attempt to map the Flint data using QGIS, following along with the posted video. If you can't map this data using QGIS, that's fine. You can also look at the map embedded here and the map linked in the assignment page. We also suggest you search for additional maps to kind of practice using things like Google Scholar and using Google searches, and just practicing the general ability to find relevant articles, which you'll need for your final paper. And everything you need to complete this assignment is contained in that assignments page. We do not require that you go out and make a GIS map, although we do enable you to do so if you would like. So if you look at the assignment questions, what we would like you to do, we hope that you answer the questions in at least 3 pages total. We hope that you attach screenshots of your map and the legends that you are using if possible. If you have any questions, you're always welcome to email me, and that is true anytime. So if you have any questions at all throughout your process of going through the materials, you're welcome to email me, and I will help you where I can. The first question we have here is there any relationship between the features with high lead concentrations in the Flint River? This question is saying, is there a relation between features, where a feature is a specific geographic subset of an area? So if I say, look up quickly a U.S. map here, the features in this case, if I had data attached to these shapefiles, the features would be available here. We could see New York would be a feature, Vermont would be a feature, Massachusetts would be a feature, etc. And we would have data at the level of state, and we would have those features. So in our case, features are wards. We have ward data available for Flint, and that's what we'll be working with today. So we're saying, is there any relation between the features or the wards with high lead concentrations in the Flint River? Based on what you have read about in the lead contamination issue, what was your response for assignment 1, and was it justified? Why or why not? The second question is, do you think proximity to the river, so how geographically close you are to the river, to the water body, affects the sampled lead concentration based on your maps? Why or why not? Does this effect vary depending on how you classify your data? If you didn't complete a map, look for one online, add it to your document, and add the above questions. And we'll walk through that today. Why would an average lead value be dangerous here? If you didn't complete a map, look for one online, add it to your document, and answer the above questions. Now, one thing to note, an average value would take very high values and very low values and collapse them to a single value. Now, there is a risk here. The risk is that if we collapse those values down, some of the high values and some of the very low values might be either over or undercounted. So this could be dangerous if we don't have an estimate of the variability. Finally, what, if anything, can a map tell us that other data sets cannot? We'll want to list at least 2 items. And this is a conceptual question. What area of Flint is likely most vulnerable and why? If you can't tell or you don't know enough to tell, state what information you'd want to have in order to know the answer to this question. And we will grade you on attempting to map the Flint River area, either by using one of our maps or finding one of your own or creating your own, and that you've showed or speculated on the usefulness of classification methods for assessing exposure to lead. We hope that you'll answer these questions in depth with well-formatted cited responses, etc. So, one thing to note is that there's a great walkthrough that kind of supplements this, available right here by Ashwari of NCAT. If you want to see the original thing, you just click on this link and you can see it right there. So the first thing we'll want to do is download QGIS. If you haven't done this before, I think I can do this, yep, to create a new tab. And if you go to QGIS, or if you just even search QGIS, the first link will be the QGIS project. You can click on Download Now. If you're on Windows, you can download this one. If you're on a Mac, just click on Download for Mac OS X and download the first one here. I suggest the long-term release. It's a little more stable. I also suggest doing the OS Go4W, and you can choose the release you'd like there. So that's a great option. So you download that, run it. It's an exe. You could also download this. And there are instructions available for you to do that. If you go to up here to the modules, and if we scroll down, we can see here the walkthrough for tutorial 3, which is where this will be posted. Tutorial 2, how to install. This will give you information on how to install QGIS. Just follow those steps. And some introduction tutorial slides there, which are the slides that Ashwari of NCAT provided. So what we'll do now is download tutorial 2 data. So I've actually already downloaded this, but if you click on this, you can click here. It is a zip file, so we'll need to unzip it. And I'll just download this to my downloads and save it there. I'll click Show in Folder to activate or to download this, and then I will right-click on it and extract all. In Mac, you could just double-click on it, and it will automatically extract all. We see a folder in here, Flint Data. So I will open up QGIS, and we will want to start working with this Flint data. And so to do this, I might want to create a new project. I can go Project New, and I've created a new project. I can highlight all of these data. Now note, I need to pull in every single file from this. Each shapefile consists of many separate files, of which are part of a single file. So it really is required that we pull in all of them. So in my case, I'm going to use Control-A. On a Mac, I would use Command-A to highlight all the files. I could also click and drag, hold down Shift, and highlight all the files. But I'll drag this down and drop them here. And I see that I have all the data that I would expect. By default, QGIS, when you pull in the files that aren't just the shape files, because we have some duplicates here, it actually pulls in those duplicates, and I don't need them, so I'm just going to remove them. I'll highlight this, right-click, remove layer. Highlight these, right-click, remove layer. And finally, highlight one of the Flint rivers, right-click, remove layer. The next thing, oh, I see another one, right-click, remove layer. Perfect. So now the first thing I might want to do is change how these are displayed. So if I double-click on Flint River, I can change the formatting of this. I can click on Simple Line here. I want to change the stroke width to something like 4 millimeters. I also might want to change the color. So I click on the color bar here, and I can change this to whichever color I'd like. I'd like it to be a nice blue. Maybe a little more on the blue spectrum. Right about here. I could even move this down to something like this, which might be a little nicer. Okay, I like that. Now I click Apply, and there's this nice blue color right in the center of our work. All right, so if we go back to the questions right here, we might be wondering about quantile and how to do this quantile layer. Well, to get started, we want to look at the demographic data, or the sampling data. Let me pull this up. And we see that there's some missing values here, some wards that are missing. We might want to start looking at the data in here. And now, one thing to note is that all of these shapes actually have data attached to them. And so if we look at the source fields, we can see that there is a field for object ID, that's the actual objects, those feature classes. zip ward, which is the zip code of the wards, draw 1, draw 2, draw 3, and sample size. Draw 1, draw 2, and draw 3 are the very same things we dealt with in tutorial 1, the draws of water and the associated lead contamination that was detected. And so if I double click on this, I go to symbology here. I may want to show a graduated based color scale. And so I click up here, I click to graduated. Then I can choose my column. Let's say I want to choose draw 1. I can see that I can actually start working with this. But in order to do this, I have to classify these. So if I could classify it, we'll break apart these values based on the mode that I select here. Note, quantile is our second selection. Let's also select that and re-click classify. We're always going to want to re-click classify once we do that. And it will change those values. See how those change? Classify. Excellent. Now we click apply. And we can see that now we've classified our data with quantile breaks, where the red color is a high color of parts per billion of lead, and the white color, or lighter color, is a lower color of parts per billion of lead. Now if I wanted, I could change this color map just by clicking on that color icon and changing these values here. I could change my color to anything just as I did before. Let's say I wanted it to be black. I could have a grayscale color just like that. Alright, so these are the quantile. If I wanted to switch it to equal interval, I could right click on this, go to duplicate. I've now made a copy of it. I can double click on it and change my value to equal interval. Re-click classify just to be sure. It normally updates, but I like to click it for fun. And I can see, and if I use a different color ramp, it'll be even more obvious. It's a little bright, but that's okay. And if I pull this up and show it, you can see, shouldn't click too much, you can see there is a slight difference. Not too much of a difference, actually. They're very similar. The breaks are fairly similar. But you can see some really small differences, say this one here, or maybe more well represented with this one. And so you can play around with the differences between the classifications. You might want to look up the statistical basis for each method. I would suggest you do that as well. If you haven't heard of how to do that, or maybe you feel a little uncomfortable doing that, how you would do that is you would look up something like quantile breaks, GIS. It's a good start. And we can see here from Esri, a different manufacturer of things, we can see equal interval divides the range of attributes into equal size subranges. This is best applied to familiar data ranges such as percentages and temperature. Quantiles, it goes into all of these details. So this is a great option to look into, and there's lots of resources like this with a quick Google. Again, I looked up quantile breaks GIS, and that will work pretty well for you. So we've gone through and we've created the data, we've looked at the distribution of the data, and we've started to change things around with how we display it. If we wanted to look at demographic data, one thing we could do is something called a join. So if I go down here to joins on this demographic data, I'll bring this up. I want to add a join down here. I can then select sampling data, which is the one that I was just working with. And I can select a join field. Now, for every join I'm doing, I want the join field to match between the two shapefiles. I always want to have a matching join key to be able to join on. And in this case, the zip codes of the wards will allow us to work with this. So I can click apply. And now if I look at demographic data and I double click it as if I was going to symbolize before by going to graduated, and I look at these drop downs, I can see that I can now access all of the sampling data within this section. So I could look at things like I could look at, say, the amount of people over 65 divided by the amount of lead, and if I thought that that was a useful normalization for my data. So again, to do that, I just went to the Join section under the shapefile itself. Awesome. Well, I hope you enjoyed this introduction to QGIS and water sampling. If you have any questions, you're always welcome to reach out, and thanks for your time. Have a great one.